we're live. That looks better. Is it coming? Awesome. Okay, can the YouTube live stream hear me? Is the audio okay? Yeah, awesome, thank you. And then one more thing. Test, test. Yep. All right. Let's see if this works. Yep. All right, let's see if this is working now. Oh my God, okay. Here we go. So that was a clear user experience problem. There are two buttons. One says laptop streaming, the other one says laptop USB-C streaming. Both apparently use the same input. All right. Welcome back, everybody. I spent half an afternoon to fix the setup from last week, from Tuesday. That was quite the disaster, so apologies again for this. And there were a few questions left that were asked on Tuesday that I wanted to recapitulate today. I want to speak about them again. We only spent half an hour today on the lecture, maybe 35 minutes, and then for the second 3 quarters of the lecture, we have Juliana today here who will walk you through iteration 2. She is the expert in that, and she will answer all your questions and will spend a considerable amount of time on iteration 2 for you. And I think that's what most of you are here for anyway, because that's the very interesting part. All right. Quick recapitulation. So at the end of Tuesday, we were a little bit in a rush, and there was a mistake that I made. You remember what this interface is? The API client, right? Do you remember seeing this one? Hold on. Our API client, this thingy. We use this to test our GET requests, POST requests, delete, and put, and so on. And there was a little mistake, namely that I sent a string in this JSON file to our server. Of course, that worked because our server didn't test for the type. It didn't check. So it looked like it's working, but actually it should have been a number. So don't use double quotation marks when it comes to sending years, numbers, and so on. Because if the server tests for the type, there would be problems. All right. Secondly, what I wasn't aware of, but I know now, we are not using TS Node this term, but we're actually using TSX. So I'm a bit older than you and a bit slower, probably as well. So I'm used to TS Node, but I was told that we're going with TSX, so I have updated this, and now we're using this more faster, modern, slicker way of running our TypeScript. Okay, just a little bit. Then there was a question in the audience. In the beginning, I asked the question, what are servers, what are clients, and so on. And someone asks, so what kind of calculation or complex calculations are done on server sites? And I was thinking about what could be a better example to explain this than what we did on Tuesday. And one example is if you interact, for example, with an AI or generative AI model that is very heavy and is not running on your local device, for example, your computer or your phone, of course, your data is sent to the server and then somewhere on server side processed. Another example is if you order deliveries. Here a picture from DHL, for example. The trucks, today in modern days, the trucks are connected. Their GPS signals are sent to some central server station. They're not processed on the truck or on the phone of the driver, but they're processed centrally on server side, and then that server basically calculates, for example, an optimal route or timings and so on, and sends up-to-date information to when your package is going to be arriving. Again, here the heavier, more complex calculations are done on server side. All right?
The screen looks frozen on the
Oh, sorry for that. Streaming. That doesn't look good, this monkey. Hold on. Sorry, YouTube. Still not up. Still. Yeah.
Yeah, it's definitely live. It just looks like your keynote's not sharing properly.
I'm actually sharing my screen,
It looks like, yeah.
but I'm also not really moving, right? Oh, no, I am.
It's live for you, yeah. It's just the keynote. Like when you swap screens, it doesn't swap on the YouTube.
Should be a screen capture. Oh, another problem. It doesn't, huh?
OBS.
Oh.
Maybe you can just drag the slides on top of OBS.
What do you mean?
Like, see how you've got like two Mac screens? If you try and bring the slides
On the same screen?
Yeah, on that one, yeah. And we can see if they will update on YouTube.
It's happening down there, but it's not happening on the stream.
It's just a bit delayed, so we'll see. Maybe not.
Any OBS experts in the room? Why is Keynote not streamed?
What screen is OBS capturing right
This one.
That's so weird.
But it doesn't show Keynote. Why is that? Funny. All right. What do I do? Another technical problem.
Can you use this screen? For the
I
slides?
see. Oh, that's Tuesday. It's the wrong lecture. Fantastic.
Can you just use this one instead of the
Yeah, I can use that.
screen?
Is that visible somehow on the screen? Screen. stream. If I do this. Okay, let's hope this works now. Still not? What's wrong? Why doesn't it like slides? That makes no sense at all. Okay, I can export it to a PDF quickly. Let's see if that works. Sorry for that. That must be it.
It's just delayed by like 10 seconds.
It's like 10 seconds or so, right?
No, because you can see it on the screen there, but not on the
This is so
screen.
funky.
Oh, is that?
Video capture is me, that works. Screen capture. But then it only captures.
Yeah. You can just try it again. Oh, this is looking better. Okay, it looks just like a bug with OBS or something. Yeah, they're saying it's working, but
Let's see, please, please, please.
1 second. Yeah, cool. That looks.
And the full screen as well. That would be even better. Yep. Awesome. Okay, here we go. Now people on YouTube can also see what we're doing. All right, so, sorry, there was a question that why don't we use HTTPS if we want to send safety-sensitive information or requests through a URL? It's a very good question, and since I'm not working in web development or anything or in cybersecurity, I had to look it up myself. But obviously, or apparently, HTTPS encrypts everything that you send. So the URL path, the request headers, the request body, so also the body that we use for post and put requests, and the query parameters in the URL. The problem, however, is if you send something in a URL, even if it's encrypted, it's recorded somewhere in the cache, for example, or in logs, or in your browser history. And if something is recorded, of course, it's more vulnerable to being hacked or breached. Therefore, it's not recommended to send passwords and sensitive information through URLs, okay? Whereas if you are putting these kind of information into the post body, they are not visible in logs, they won't be recorded, and they are safer. That is the short answer. If you're more interested in this kind of question, please dig a little bit deeper, but this is the quick answer to this question. Next one. We talked about these 4 methods last week, right? CRUD. Can someone tell me quickly what CRUD means? What do the letters stand for? What requests do they each require? Anybody? I know you know it. Any idea? Not yet? No problem. Any idea? No? Wow. Please, do you mind using the mic? Thanks.
Create, read, update, and delete.
And can you tell me which of the HTTP methods or request methods we use? What they are called?
I remember one's put.
Put, exactly.
Delete stays the same.
Delete is the easiest, yes, correct. Which one is put?
Is it update?
Yeah.
I don't remember the other 2.
What is read? What do you do with a book when you go to a library? You go to, perfect, get a book. And how do you create an entry? Correct, post. So we have post, create, get, read, put, update, and delete this way. All right? So these are the 4 methods you have to know and you will have to use in your iteration too. Okay, and last but not least, a little fun question. Do you know what this is and what it stands for and what it refers to? Whew. Correct, that's jest. What is jest?
Jest allows you to effectively run black box testing on your on the software. You can provide ODML to create a pipeline so you test it when you master.
It's a testing framework that we use, for example, to test functions, input, output, are they correct? Or we also, as we have now learned, to create our own servers, write our own servers. We're now testing servers. What can you imagine? What is there on a server that we want to test? Any ideas? So think about what you have learned about functions. Yeah, and what in the API? Yes? Any idea what we want to test? So what do we do with the server when we interact with the server?
Isn't there like the codes which like 200 for 200?
Yes, these are HTTP responses. Yes, response or status codes. Yes, we'll talk about them later. But what else do? We send a request and we want a response, correct. So what we can test using Jest is that these request-response pairs or expectations of what we want to get match the actual output or the actual response the server sends to us, okay? And that's what we're going to look at today. So we're talking about server testing. And since, as I already mentioned, we stopped, or now we started writing our own APIs, so these little rules that we put in between the server creation and the server start. We want to now test that these rules are actually working and that our API is functioning. And again, we want to test that the request-response pairs or request-response pairs are actually correct. And for this, there are different ways of doing this. First, we start with a little library that makes it possible for us to do this through code. So not through API clients anymore, not through the URL in a browser. And this is this package called sync request curl, and the little trivia about this was actually written by a student of 1531 a few years back and who then became a tutor as well. You remember I showed you, wrong browser, I showed you this website last week, NPM, Node Package Manager. Sorry. And on here you can search for the name for this package called sync request curl. This is it, and that is what it looks like. Hold on. Exactly, this is this package, and you can see we have about 3,000, 2,500 downloads per week, which is a great number. And there's documentation to it, so if you want to learn how to use it, which I highly recommend, and you should, you can look, for example, under the methods tab, and then here you have the example on how to write a GET request without options and so on. I will not walk you through all this code right now. I'll just show you where to find it, but we'll look at an example, okay? And the example is, I think, yeah. We have here. So first of all, of course, logically, if we want to test a server, what is the first thing we need? We need to run a server, right? We need to have something running, something listening, a server listening on a port, and then we want to test that server specifically. So now here's our old example. You remember the library we had, booklib. After installing sync request curl, I've already installed it, but if you want to do it, just a little hint, you can find the installation prompt up here. You can easily copy it and just run it in your terminal or in the terminal in VS Code, for example. And we want to run this server now. What's our port? Can you tell me again what a port is, quickly? Anybody? Volunteers? What's a port? Nope. Nobody? Wow.
From what I remember, a port is a, like, what was it? Like a door to the server you want? Like, what was it? Like the label to a door.
Correct. So you have multiple programs running on your computer. Certain programs can respond to certain requests, and the port decides which request is led to which program. And you have to match it so that your request, the correct request, matches the program that can work with it. That's the easiest way of explaining it. Okay? So we have to run this. Can you remember what this nodemon package is that we installed last week that helps us with updating a server, for example, when we change something in our code, right? You remember, usually when we change something in our code, we want to test what the change does. We have to terminate the process. So we close the server, so to speak, save the file that we changed, and restart it. And with this nodemon package that helps us do this automatically, I'll use that today for you. And remember, we're using nodemon. And then we open this file, booklib.ts. That should now be running on port. So this server is now listening on port 3000 as we defined up here. Okay, that's where our little book library is on that server with our 2 books. Fantastic, not much. So now we have a server running, and now we want to send some synchronized tests, some synchronized requests. And for this we use this package sync request curl. So we have a server, and that file is in requests.ts. That file, you all have them available. This is what that looks like. Okay, the sync request file. You see, so we import the request function from the sync request curl package or library, and then we declare a variable res or a constant that keeps or that stores the information that the request function produces. And in this case, that would be we're sending a post request to our server to create a book entry, right, in our library. That's what it is. And the response is then saved in res. And the advantage of this sync request curl package is that we can synchronously send another request down here. So we're sending this get request, and the response to this is saved in another variable or constant, which we call res1. The naming is up to you. And then last but not least, we console log the results of this little test. So let's try this. This is request here, so tsx. Hold on. Sorry, no. We do npx tsx and then requests. It's a plural, ts. Okay, and then we should get an error message, funnily. What is wrong? Did I make, good Lord. Probably a typo somewhere. Hold on, I cannot find module. Oh, I'm in the wrong folder, of course. And then we do the same again. And now, yeah, okay. Now we have the results. So our first response is the creation of this new title under ID 3 is hello everyone. That's taken from up here. You see that. The author is this time a number. Should probably be a string, but we decided it's 1531 as a number. And then the year that book was written is 2025. And you see the entry down here. And then next, the next request is to get the information of all the books in our array. And here we have the initial ones, the Hobbit in 1984 that you see that were already in our server, or on our server, sorry. And the added one was added as ID 3 down here. Okay? Yes, please.
What does like JSON.parse do?
Well, it hold on. Oh, it passes the JSON information from this body, get body, and returns it to us down here, right? No? Yes. Is what I think. Yeah, so we are outputting the post, outputting the response from the post request. This is from up here, and it passes the JSON information from this response. Yes?
Why did you put the link in the const res 1 equals request?
Sorry, the link?
Yeah, why you put the link in there?
Here?
There,
What do you mean with link?
yeah,
The URL?
Yeah, the URL.
Because we have to send the request to a certain URL, to a certain endpoint. So this is a different piece of code, right? A different piece of code than our actual server. We just have to tell them where to check, where the server lies, where the server is, where that information is. So that's why we have to give this endpoint or this link URL.
Okay.
Yeah?
In this case, is the book library kind of like the server, and then the request is what you're doing just to access what's on the server?
Yeah. And there are two ways of accessing now, two of the 4 CRUD methods we used here. One is to create a new post or to create a new entry by using post, and one to read the information off of. So what's on there? What's in that server? What have we stored so far? Okay? All right. Let's move on. So now we have looked at this, and now we can use the actual JEST framework. We're going to look at how we do this now to do server testing. So this was just a tool to send synchronized requests using this sync request curl package. And now we're working with JEST. And for this, we'll open a slightly bigger piece of code that we have prepared. But I'm first going to walk you through this very briefly. So here, this describe function is part of our JEST framework. That helps us to group related tests together. You see that we have this label or the first argument that is called test get. So you can name it as you want, and the second argument is your callback function. Then in the next line, we define the individual test cases with a description under, again, a function from the JEST framework called test. And here again, we have a label, or the first argument is the label if it returns a book info successfully, and then the second argument is our callback function that contains the rules of what is going to happen. All right, then we declare a constant again, a response one, and it stores the response from the request, get request that we send to this specific location. Here, in this case, we send the location to ID 1. What does it mean? Are we getting the full list of books? Correct, just the first one. And then here is the explanation. Here we convert the response to a string and store it in the body object variable. All right, and then this important part is this last part where we have this function expect. This is where we define basically what the response we get back from the server should look like. And that is what we compare the actual response to, and just helps us with doing this. In the code I'm showing you, we have 2 expectations. The first one is that the get response for book or ID 1 looks like this. It's ID 1, title, The Hobbit, author, J.R. Tolkien, and the year it was written, which I don't remember, 1937. And the second expectation is for a post request, namely that we create a new book called title, that has a title, sorry. The title is taken from up there, author and year in ID 16. So our assumption here, and that's important, is that we expect there to be 15 books already in this array, okay? This is what we define. We think, okay, there's 1 million books in this, and I want to add another one at position 1,000,001, or in this case 16. But you know how many we have in our array already. How many do we have? You know what's on our booklib server? No? So far we have 2, okay? After this we have 3 because we post a new one. So we would what would you think this ID should actually be like? What should it be? Sorry? If we post 1 to it, 3 or 4? We can try. Okay? And then last, who does remember how we run jest tests? What is our little command that we put in? You should remember.
npm test by npm t.
npm jest,
Test. Oh, yeah, jest.
and then the
Change
final.
the
Yes.
script, you can do t test.
Okay. I have this super animation for you. We're using npx jest request, and that's just a file number. Okay, let's try this out. So let's look at it. It is requests test. This is again the file. You see here we have the describe function test. Localhost is we're going at 3,000. Books 1. So all you said 4, right? 4 or 3 as an ID. What was your guess? 3, you said. All right. Let's try 3 and run this baby. Sorry? Too late. Let's see. Maybe you're right. Good job. You're correct. So what you see here now in this message is that here's the detailed information. The get test was successful, so it returned exactly what we expected in our expect function. Our assumption was correct, and the same is for the post test is also correct. And we can see this here, it passed. Let's change this. Change this to show you what it looks like if there's a mistake. 127, and run this again. Now you see that one test is correct, the get test is correct, so it returned the first book in our array correctly on the server, but the post test was unsuccessful. And why? It tells you we expected an ID of 127, so we expected there to be already 126 books in this array, but actually there are only 3 so far. And this is how you can test your server using Jest, the Jest framework. All right. Next, we have what you already addressed, our HTTP responses or response status codes. So you all know this one, of course, 404. Everybody has seen this a million times. Why do we use these kind of codes? So there's a database. I can show you where you can find these codes. These are the 3 main categories. So all the 200s basically are success responses. The 400s are something where the client makes an error or there was an error on the client side, sorry, not makes an error. And the 500s are server-side errors. And we use these codes to tell people, for example, tell a client or tell another developer who works in a different team or so what's going on, what's wrong, or what's correct, all right? Rather than guessing, okay, maybe I have a typo in here, maybe there's a file not existing on the server side or whatsoever, these codes give you more information. And I'll show you a quick website where you can see HTTP status codes. You can easily find this. So there's a whole list, a whole database of them. So for example, 200, okay, the request succeeded, the results in meaning, and so on and so on. And as an example that I'm not making all this up, we can look at Tuesday's API client again. For example, here we sent a GET request and we got a 200, it was okay. We had a 204 for delete, which was okay. Do I have probably can create an error easily. I'll just delete this comma here. We should get a 400, which is a bad request. So here we get an error message because in this JSON there is a comma missing, right? So this is what these status codes are used for, to tell us basically what is going on, what's going wrong. And it's important for people, developers, clients, or people, if you work in bigger teams, imagine you're working for, I don't know, YouTube or Netflix and so on, and you're working on the front end, so everything the person, the user, the customer sees. and you're meant to test a new function that the back-end people, the people working on the servers and calculations have implemented, and you try it, and you get error messages that are not defined or that are unclear to you what it means. It's very hard to report what your experience was. So these codes make it much easier for you to tell the developers, hey, look, I got this 404 code, so something couldn't be found. Or I got a 201, this was successful, and so on. So these codes are very good for communicating and making clear what the problem is and where it can be found. And to formalize them and make these codes machine readable, because imagine a software like Netflix or Facebook or so, they have, I don't know how many functions they have, and I don't know how many request response pairs there are possible, but the lists are endlessly long. So doing this manually is not possible. So what you need is you need machine readable, we call them API contracts, or the old term was also Swagger files, which is quite funny. Now they think they call them Open API. And we need these files to basically document the possible API endpoints. Again, these are the specific URLs that point at a certain location in the server or a certain file in the server. The expected parameters, so what do we want to get after a request, the possible response codes, and status codes, and we describe the response body structure. And what these Swagger files look like, I'll show you here. We have one as an example. They basically look a little bit similar to JSON files, but are YAML files usually. And here you see Open API, so we don't call it Swagger anymore. This is the URL where the server should be sitting. So this is, of course, something we have to change because we're currently, our server is on localhost 3000. And then you have all these rules and the summary of what's been done. The get, for example, the get request is to retrieve information from all books, and then what the format looks like. So what's in there? There's an integer, there are strings, and so on. And this file is rather, well, this one is not so long, but I can show you an example of a long one. Swagger editor. Let's say you have 10 to 15 endpoints on your server. You probably write these things yourself. If you have like 400 or 500 endpoints, you won't do this anymore. So you have editors like this one that you can use. You can edit information and live updates. For example, everything about your pets and car. If you do this, you see it automatically updates the information in here on the graphical user interface. And here you can see examples. There's a put request, right? What does a put request do? You can try it out. I'll show you a slightly smaller example that we have made available for you. Oops, not WhatsApp. That is, we need to open a library. We have a special library, book library underscore Swagger, and we run this on port 3001. So that contains these special elements that you need to open the YAML file or the Swagger file that we have and to actually play around with it and try it out. Okay, so I'll run this quickly for you because we're a bit short on time. Bookleap. Okay, that's running on port 3001, so we go 1. However, if you go there, there's nothing going to happen. It cannot get. The reason is that we actually have a special endpoint for this, and that is this one, API docs. That's where the Swagger UI can be found. So we add this here. And now you see this is the our Swagger file. This gives us all these rules and that we have in here. For example, retrieve information from all books. I'm rushing this a little bit, sorry. Get the information so you can try it out. You'll execute it, and it will show you what it did, where it looked, and the information it found. So here's the response body. The code is 200, so it was successful. and it retrieved the correct information of the 2 books we have in there. And there's a response header that Juliana will in a second explain what headers are, basically metadata, and so on. You can do the same for post. So let's have a quick look at post. You can try it out. How does it work? You fill in the information. A funky book by an even funkier author from the year 2000 or 3874. You execute this, and here's your book entry. It's also successful. You posted this successful to your server, okay? All right, and I think I'm a bit over time, as usual. This is the example we just walked through. Yeah, okay, so in summary, we can test servers. That's what we briefly looked at today through code. Of course, you have to have a server running first. We use HTTP status codes, these funky 3-digit numbers, to communicate the status of our request, the status of the server, and the responses. And we have these Swagger files now called OpenAPI that basically summarize all these rules for request-response pairs in a machine-readable format. Sorry. And they are usually written in YAML or JSON. In this case, it was YAML. Okay. Juliana, are you ready? Awesome. All right, thank you, everybody. You want to share via Teams, right?
Yeah, maybe that'll be easiest.
Okay. We'll be right back on YouTube.
Now
Just
off
have to
mute.
click once. Yeah.
Yep, okay. Very good.
Can you say something?
Hello.
Yeah.
Hello, good. All right,
And this is
Awesome.
for the room.
cool,
The second mic.
cool, cool.
All right.
All right. Hey everyone, I'm Juliana. I am one of the project admins for this course. In my daytime, I am usually a security engineer for Atlassian. I did this course and I tutored this course and now I help run this course while I do work at the same time. A lot of tutors do that too. So this project, a lot of you very familiar with it because you've already done iteration 1. Well done, getting through the first iteration. You've only got 2 more to go. This iteration is going to focus a lot on HTTP, obviously, with what you've been learning in the lectures. So what we're going to do is we're going to take everything we've completed in iteration 1 and somehow turn that into a HTTP server with HTTP tests and then build upon that, right? So by the end of iteration 2, you're going to have a back end that's going to be able to power this amazing looking front end that our wonderful tutors have built. And you'll be able to do all of these features. Register, which you might remember having to implement a register function in iteration 1. And obviously this account already exists, so we'll make another account. And you'll be able to log in and you'll be able to create quizzes and play around with it, which is going to be fantastic. Now, you don't build the front end as part of this course, you're just building the back end, but we give you a provided front end that you're going to be able to connect, and I'll show you how to do that in this lecture as well. But super exciting, right? You get to turn something that you build into something you can actually use, right? So yeah, that's going to be most of your iteration 2. So let's have a look at the spec. Hands up if you've read the spec yet for iteration 2. Yeah, a few of you? Yeah, that's good, good. Hands up if you've had a meeting with your group and discussed the spec. That's good. Okay, so iteration 2 will feel slightly harder than iteration 1, so my advice is don't leave it till like week 6 to complete. It's due on the Monday of week 7, so please don't leave it till that weekend to complete. And just to add to that, week 6 is obviously flex week, so you won't have a tutorial or a lab to get help from your tutors. So my advice, start this week, get help from your tutors next week in week 5, and then you can kind of just chug along and do the coding and stuff if you need to do some more work in week 6, and hopefully things feel less stressful for you. So that's my advice. But do with that what you will. Okay, so let's take a look at the spec. Like I mentioned, the main thing is going to be how do we convert all the work we've done in iteration 1.2, I guess, part 2 of iteration 1, into a HTTP server and have that working, and I'll show you a quick demo of that today. The next thing you're going to have to do is migrate your JavaScript files. I might make this slightly bigger because I just noticed the text is tiny. The next thing you have to do is convert your JavaScript files into TypeScript. This is fairly easy. It just involves mostly changing the file extension of the files and then some of the type definitions. Let me scroll down. There we go. Okay, we're back. And implementing your server. Then you'll also have to add ESLint. So lint your code. This is also fairly simple. There's commands that have been added to your project if you've already accepted the merge request that will help you do this. And you're going to be marked on whether or not your pipeline is passing. So you'll notice that this repo might have it already. Yep, this little tick up here, that's the pipeline running for the big admin repo, which is how we send out your project. And you can see here, all it's done is it started the server and it's just checking if echo is working, right? Because that's all we give you in the starter code. So you'll want to make sure that that pipeline is always passing, got that lovely green tick as well. So that's something new in iteration 2. If we have a look at, yes, is this up here? Yep, okay. Keep jumping around. Yeah, all right. This section is very, very similar to iteration 1, where you're going to have meetings, document your meetings in a valid meeting minutes format. We have a suggested one in the project spec if you haven't looked at that already. You're going to have to show that you're having regular meetings as well, at least 2 a week. All those good Git practices that have been taught to you using the issue board, individual reflections and all of that. I'll go through that once we open up the actual source files of the spec. There's some advice here on how to tackle type errors. So running npm run tsc and being able to fix them. And you can also utilize the ts no check annotation, which essentially will just skip that line for checking its type. That is something that you can use while you're working on the project, but you can't submit your project with that in it, because obviously if you put that line at the top of every single file, then you're going to exclude your whole project from being type checked, which your tutors will definitely catch on to and mark you down for. So it can be used while you work on the project, but make sure you don't leave any in there when you go to submit it. Running the server, you're all familiar with how to run npm start now. Implementing testing features, we'll go through that. We'll come back to this when we do the demo. Yeah, we'll come back to all this stuff. Great, okay, so let's just start off with a quick demo then, and then we can jump back to the specs. So, most of you might have, let's zoom in a bit. Yep, most of you have probably already opened up this server.ts file, at least those in the room. This is where your server has been largely defined and where you're going to define all of your routes, right? So if we have a quick look through this and unpack what it's doing, it's starting the web app. It's using some middlewares that are just going to help make your life easier. These you do not need to edit or touch. And same here. This is just serving the OpenAPI spec, the Swagger document that has all the routes defined. And then this, where you've got these massive comments that say, work is done below this line and work is done, please follow this suggestion and do your work below and above these lines. It's mostly for auto marking purposes. If you start messing about with things around there, we can't guarantee that your auto marks are going to be what you expect. So we just ask that you define all of your routes inside of those commented lines. Now you can see we've got an example in here, echo, which is also based on the echo function that you got given in iteration 1. You'll notice we have two new echo files as well. We have new echo.test.ts and new echo.ts, and these are just going to show you how you might go from iteration 1 to iteration 2. I'll come back to that in a minute. So let's unpack what's going on here. Most of you should be familiar with how routes are defined in servers, in Express servers in particular, how you define the HTTP method and then the route, and then you have calling your backend implementation, wherever that is. In our case, it's defined in one of the echo files, a separate file. It's taking a query parameter here, so one provided by the user echo, and then it's looking for an error. If it has an error, it responds with a status code of 400 and logs the result, right? So pretty straightforward. Let's go to the top of file and figure out where's this echo coming from. You can see it's being imported from new echo. So let's hop over to new echo and see what's in this file. This is just a type checked version of the original echo file to also give you an idea of not only how you might want to change your backend functionality to better suit the new HTTP routes, but how to type check them, which is most of what you'll be changing. Because you'll notice if I split screen this file with the original one, right, there's really not much difference at all. Like we're still checking if echo exists. Maybe this time we've decided to check if the key actually exists as well as if echo is echo, because we don't want people echoing echo for some reason in this route. And then the return object is essentially the exact same thing as well, right? The only thing different is how you've got a type-checked error message. So very similar. So if we look at this method then, and we compare it to what's happening in the server, yep, cool. All it's doing is it's passing whatever the value of the echo query parameter is to your backend implementation, your function defined somewhere, right? So this one here. So let's just npm start this and test it out really quickly. So just got the REST client opened. You could also run your jest tests, either or here. If we echo, we should get that 400 error that we were expecting, right? Because you apparently can't echo for this route. So yeah, you see in this here, it says invalid echo. I know it's a bit small. You can't echo the word echo itself. Great, okay, so what if we change this to something else? Then it will echo it back, right? So when you npm run start your server for the very first time after accepting the merge request from iteration 1 to iteration 2, this should be fully functional, right? You can run your server, you can interact with echo. But now you're like, okay, well, I've got all of these methods defined in, or functions defined in other classes in auth.js. You'll have an auth register. You'll have quiz functions inside of quiz. How do I turn them into roots, right? It's quite simply just defining the root inside of this file. So you obviously want to import it at the top. Let's assume that there's an auth register inside of auth.js right now because it's JS file, but you want to convert that to TS as well. And then let's use that here. So app.authRegister is a post. And if you're like, okay, well, now I'm stuck. What is the root supposed to look like? That's all good. We can go and check out the Swagger files. So this is also in your project backend, right? Just click on the Swagger. It will render with GitLab, or you can render it yourself if you just go to the local host, what is it, 127.0.0.1. And the port is 3200/docs, I think it is. Yep, they're also there as well. So use whichever you prefer. But if we look at it on GitLab, you can see that the endpoint needs to be defined as v1 admin auth register. So I'm literally going to write that exact thing, admin auth register. Great. And then this is all, it's going to look very similar. So for now, I'm just going to copy and paste it so we have a boilerplate. But instead of calling echo, what should we call? Does anyone know? If we're writing an endpoint for admin auth register, what would we be calling instead of echo? Auth register, right? From your auth file that you should all have already completed from iteration 1. So let's assume that you called it admin auth register. You might have called it something else. It's likely called admin auth register. So we'll write it here, great. And then we'll assume it exists for now. And instead of taking this request query echo, we're going to want to take what admin auth register expects. So let's go back to the Swagger docs and see what does it expect, right? It's expecting a post body with an email, password, name first, and name last. If you're unsure of what type these values are, I know it might be obvious to you that they're all strings, but for some of the endpoints it might not be as obvious, especially for the new ones that aren't based on iteration 1. You can click on the model and then take a look and it will tell you that they are in fact all strings, okay? So that's good. We can grab them from, no, I don't think we have an admin auth register defined yet, but that's okay. Go email, first name, oh, that auto completed. Last name, what was the other field? Email, password. Great. Request.body, I think. Okay, you can unpack it this way. I don't know if that will, you know, actually run properly, but we'll find out, So this is probably a good spot to go and check what's in auth, which is absolutely nothing, and quickly give ourselves just a stub. Obviously you'll have the actual answer, but I won't give that to you because that was iteration 1. So email, password, name first, and then name last. And what we'll do is we'll just have this return a user ID for now, just like 1, because that'll be enough for what we want to do. Okay, and instead of passing this stuff in, we can now pass in, I don't know why it wants to autocomplete like that. Great, password, I think, yeah, first name, last name. Great, and then you'll grab your result, which in our case, we're expecting it to just be that user ID. You will also potentially be returning a user ID from this backend method. But the point is with a HTTP server is the server itself doesn't care what the underlying backend functions that you're calling are. You could be calling one function like admin auth register. You could be calling 10 functions and they all do different things, right? The point is that it only cares about the input, as in what the user or the client has to provide to the server, and the output, aka the status code and what it gets back. So you can have anything in here, whatever your heart's desire, as long as the client is expecting the right input parameters and then the right output. So in our case, where we can definitely check for an error in the result, but for admin auth register, you'll see that the error codes, it's still a 400 error, but the error type, I should say, they're all different to echo, because instead of having an invalid echo value, you might have an invalid email or a first name or a last name or a password. So you might check for something specific here. If the result is invalid email, then you can return the result. You don't have to check it here. You could check it in other places. The spec does give you guidelines for what we would consider to be proper style and separation of concerns, because ideally, and this is how they do it in the industry as well, you don't want to have implementation details, like the actual logic of registering a user, sitting in your server. Your server should ideally just be only what you need for the API to work in terms of accepting what it should be accepting as input and what it should be returning. So if your group's thinking about potentially raising status codes, putting that logic inside of your backend functions, for instance, inside here, like actually implementing like 400 errors here, that might not be the correct solution. You might instead want to follow the guidelines we've given you here, where all of your status code logic stays in your server, okay? Whether or not you decide to have them all repeated like this with if statements or with helper functions, that's also up to you. But the point is, we just don't want to see logic like checking here. If you were to go, oh, if email equals valid, right? That's obviously not valid JavaScript. But if you were checking email validity in here, you would get marked down. The reason being is because we expect implementation logic, like checking or not, checking if an email is valid, things like that, to go in your, essentially your iteration 1 files, your backend logic. Does anyone have questions on that? I know it can get a little bit confusing, but your server should contain your roots, right? Not the actual, if you've got, if statements checking the implementation of those roots, that can probably be moved to your implementation. But the point is, for converting your iteration 1 backend functions to HTTP routes, it should be quite simple, literally as simple as something like this, right? Where you're just calling your implementation, checking for an error, and then returning that error. Right, so what we can do is, what have we got running here? Oh yeah, that was just me grabbing the Swagger docs and running echo. We can try this again. Yeah, okay, we're gonna get a bunch of errors because I don't think I've written I haven't written valid code here, but it's probably complaining. Let me see if, yeah, this is a lot better. That's what I want. Let's grab that instead. Okay, so what was I doing wrong there? When you do it on one line, you want to unpack the object. Request.body is going to return you a JavaScript object. So if you're going to do it in one line, unpack it with the object braces around it. This will need to be password. That's fine. Okay, let's try that again. Okay, the server started, so let's go check out our REST client and see if we can test this. So it was v1 admin auth register. Yep, admin auth register. We're going to make this a post request. And then we need to give it a body. Cool. So we want an email, a password, and then I called it what, first name and last name. Now this might not be, go back and check the Swagger docs because this might not be 100% what the Swagger docs say, but it's just for demo purposes. Last name. Okay, and we can try to send that, 500. That's because this is not in quotes. Try that again. Maybe not. Oh, okay. So it's an import error. So if we have a look here, I did not export it. Admin auth register. Great. Okay, let's try that again. Restart the server. Cool. Try send that. Maybe not. Did I import it? 500 import auth is not. It's definitely a function now. Oh, it might be. Yeah, it's definitely the curly braces this time. Okay, third time's lucky. Yay, okay. So that's a very, very simple example of how you might take admin auth register, the iteration 1.2 version, and turn it into iteration to a root. Okay? Any questions on that? Yep.
Didn't you say that server would only have the API and the bare essentials, but then all your entire code will be on the server, right?
You mean as in this
All
code?
your files will be on the server, right?
What do you mean by files? Like endpoints?
The whole project backend is going to be on the server, right?
So when I say separation of concerns, I mean that logic like this, if I go if email equals, and then you want to have some sort of like, I don't know, check for if an email is valid, that all needs to stay in auth.js. That's what I mean by separating your backend logic from what goes in your server. So essentially, everything you did in iteration 1, all of that implementation detail, right? We would have had a lot of if statements written inside of this function. It would not be as bare bones as this one. That stays in auth.js, or what you're going to now turn into auth.ts. And then all you expose in the server is an endpoint that calls that backend function that you've already written. Does that make sense?
Okay, yeah.
Yeah, so, yep.
When you say root, what exactly do you mean by root?
So root is exchangeable for an endpoint, which is essentially this v1/admin/auth/register.
Just like the address.
Yeah, it's like the path, right, where you're exposing something. Any other questions? Okay, because this is what's going to make up, I think this is what confuses students most, usually, when they go to start iteration 2. A lot of people will procrastinate because they just don't know exactly how to convert their iteration 1 work to iteration 2. But hopefully this makes it a bit clearer where you're just going to be calling things that already exist. So while this one took us maybe 10 minutes to do, once you do one, the next one kind of only will take you a couple minutes because you're just kind of copying and pasting a lot of the existing root definitions, but changing the method from maybe post to put to get to delete, changing this root or endpoint definition, and then changing what you accept and return.
You said a lot of like the logic as well shouldn't be in the server.
Yep.
But for example, if error in result and result, like that logic that you have there,
Yep.
you're gonna have to use that as well. For example, for invalid password, invalid
Yep.
email. So
Yep.
there's still gonna be implementation logic in your server either way.
So that I wouldn't count it as implementation logic, given that's just checking the return, the response of essentially what these are. You're just checking like if one of these to return the right one of that, which is the status code. The reason I have it for this one is because some other methods like this one, for instance, you'll want to return a 401 for a different error string. Does that make sense? So in this case, like, what is it? Post admin quiz, right? You'll have a separate if statement that will return the status of 401 instead of just returning the result all the time, right? That's why I have an if statement here, just because the status code may change depending on what error is raised. But you probably wouldn't need it for this method in particular. Well, you would, because you need to have at least one if statement that checks if it's an error, return status 400. Otherwise, when you return res.json, the implied status code is 200, right? So you can think of this as like, in all other cases, return 200 success. But for others, you'll have else if, and then the error might be unauthorized, and then you return a different status code. But that's basically the only logic that you want to have in your server. The only logic you want to have is checking what status code to return. Does that make sense? Students get caught up on that a lot too, so it's a good question. Yep.
I'm sorry, you may have already answered this, but where do you map the endpoint to the function? How is that done?
Yeah, so this endpoint here, the v1 admin auth register, just calls this here, this yellow admin auth register. That is the backend function itself. So
Where is it mapped?
you can just import the function at the top of your server. So your imports are going to get quite chunky at the top of your server because you're going to be importing every single function from iteration 1, and then you just call it inside of the right endpoint definition. Does that make sense?
So that post actually exposes that endpoint to the outside.
So the endpoint itself is now exposed via the server, and what happens is the client will take an email, password, first name, last name, and that's kind of all it sees. It just gives you like this here. It just chucks you this data. It won't know how you're turning that into a user ID, but you'll know.
We could create any path there we wanted, but these
Yep.
have been instructed this way for us to use.
Exactly, yeah. So I could change this to whatever, logout, even though it's not a logout method, and it will still do the same thing. But the important part for you is you really want to make sure that you get these routes or paths exactly the same as what it says in the API spec, and you want to make sure that the input data and the output data is identical, because at the end of the day, that's what the auto marking is going to be doing. We're going to start your server, we're going to run tests that we've written, as well as your tests, just to make sure your tests are good too, but tests that we've written, and we're going to expect all of those routes to look exactly like this Swagger doc. Anything, even if you accidentally changed the D to a B, you'd fail all of the admin user password tests, right? So you need to make sure you really follow this specification. Why? Because that's how it works in the real world. When you have a front-end team working with a back-end team, you'll expect the front-end people will be given an API doc just like this, and they expect everything to be exactly how it's defined, for the back-end to work exactly how the docs have been written. Does that make sense? So I'll show you now as well how to run the front end. So right now we're in the project backend directory, but you're also given a project front end repo, and you can find that in the spec. If I go project front end, here it is. All of you can clone it right now, and it's a very small README. It just gives you 3 commands to run so that you can run your front end, well, the front end we provided you, with your uniquely created backend. So we can follow these instructions. It wants us to run our backend first, so we can do that. Let me just move this. Okay. We'll go back into the backend. We can set the port. Now these port and host values are just defined inside of config.json here. So if, for instance, you're working on the CSE machines and you somehow end up on the same machine as another 1531 group, that is also trying to run their server on port 3200, you'll know that ports can only host one thing, they can only expose one thing, so you can't expose your backend plus another group's backend, so you might need to change this port to like 3001 or something like that. But for our case, we want the server, as you can see here, the server's now started on 49,153, that port. And that's good because now the front end will know what to expect. The next instruction, we've already cloned it, we've CD'd in there. You just run this run front end script for the port in which your backend is running. And this 3000 port is the port that your front end is going to be exposed on. So if I run this now, cool, and I click on this, now if I hit register and I try to, it's going to say an unexpected error occurred. Does anyone know why? So it's running my backend. Here it is. Oh.
You don't have author just implemented.
Yeah, I didn't do it properly. I just returned a user ID of 1. So something is gone wrong with the implementation. So you running your backend with our provided front end, that's actually a really good way to sanity check what you have written, the code you've written, the server you've written, is actually correct. Because if you run it with the front end and you're getting errors like I'm getting, maybe you've done something wrong. So it's a very good way for you to, basically sanity check everything. And also, when you do your iteration 2 demo with your tutor, you will have to show your server running with the provided front end as well. So it's part of the demo. So what I would suggest is that once you've added in all of the root definitions for your iteration 1 routes, give it a go. Run the front end, see if it works correctly, and you'll probably be able to spot bugs if there's things that you've, say for instance, you've accidentally named user ID something else or you're not returning what's expected, you'll know. Any questions on running the front end?
Yeah, there's a question on YouTube.
YouTube.
Do we put all our routes in this server.ts file?
Yes, all the routes definitions go in this server.ts file. And that is because of express magic. That is where it's expecting all your routes to be. Yes?
You might have already explained this, but how does like const app equal express it really work?
I don't know. That's probably a good thing to go and read the Express docs and figure out how this function actually works. I'm sure, if you right click on it, it'll give you, this would be the implementation of how Express has magically somehow written servers. I don't know how that works.
Make the service for us?
Yeah, basically. What it does is it will take anything you've defined like app.listen, things that you've attached to the server class itself, and it will listen to what you've said. Like for instance, start my server on this host and this port, and it will create it for you. But yeah, it probably does a bunch of networking stuff that I wouldn't be able to explain. So, cool. All right, some other things that you'll need to know that are slightly different for iteration 2. If we go back to the spec and I find, no, session. Yes, okay. Cool. So user sessions. This is something that will commonly confuse students as well, so it's worth a bit of an explainer. In iteration 1, we used user ID values, and that's what I also used here when I exposed auth register as a root. But when you use websites, you think about using something like, I don't know, Reddit on your phone and your computer. When you log out on your phone, it doesn't also log out your computer and all other sessions that you have, right? It knows to just only log out that one device you have. So how is it doing that? Because if you think about how we've implemented our iteration 1 at least, all you've given a user is a user ID. Like for instance, you've given someone a user ID of 1. If you go to log them out and you try and make user ID 1 invalid, it would make it invalid everywhere. So how do websites handle this? They handle it with a concept called sessions, where each user ID would get a unique session for everywhere that they log in. Every time that they log in, they get a unique session so that when they log out, you just invalidate the one session that they used to access that device, right? So that's what we're going to implement in iteration 2. We're introducing a concept of sessions. It's like in the spec, it has an analogy here of like if you tried to board a plane with just your passport and not the boarding pass, then they don't know, like, are you allowed to be getting on that plane or any plane, or like what the deal is, right? That's what boarding passes are, essentially like sessions, but for planes, right? So that's what we want to add in iteration 2. How do we do this? Well, now you think about the concept of sessions, it seems like a pretty important piece of information. Like if I stole your session cookie that you used for Reddit and copied and pasted it in my browser, and now I'm logged in as you, that's not good, right? So sessions need to be secure. How do we secure sessions? In the real world, you probably have seen cookies. And most of the time, the session would go inside of a cookie value. We're not doing that in 1531 because it's a bit complicated and we don't have that much time to go into, it's not a security course, basically, right? So what's the next best option? The next best option for us is headers. So when we're looking at this server, right, these calls, when we go back here, for echo. You can see these are the query parameters, right? Echo equals t. T is the, echo is the query parameter and t is the value of the echo query parameter. If we were lazy and we just said, well, what if we just put the session in the query parameter, then that would expose our session value to everything in plain text, right? Not ideal. When you're using web browsers as well and you're sending that URL across whatever Wi-Fi network you're connected to, that's all, that query parameter will be shot across in plain text. Not ideal when you want to protect something. So what do we use? Headers instead. Why? Headers are encrypted in transit when they're moving across the internet. So it's a better version of just sending your session across as a query parameter. Is it as good as cookies? No. And that's for a million different reasons where you can go and read the specs on cookies and why cookies are a special type. Cookies are still sent in HTTP headers, but they're a special type of header that require lots of different data with them. But sending a session in a header, that's the next best option that we have. It's simple, but it's still mostly secure for our purposes. So that's what we're going to do for iteration 2. Now, the next question is like, okay, that's great. The idea of sessions is fantastic, but like, how do I use them? How do I actually accept a session from a client, and how do I generate them and send them back? Well, in your auth register, this result value that you're returning is essentially going to be the new session that you're giving to this user. And how do you know that? Well, it tells you here. You can see that the return type and value has changed. It's changed from a user ID to a session, okay? So it's up to you how you implement that and where you implement that. I'm not going to give you the answers because that would be solving the project for you. But essentially, you might think about in your data store, not just storing user IDs, but storing sessions with that, right? And then you can like build up, you can have multiple sessions for a user ID, and you can invalidate sessions for those user IDs, and hopefully you have a data store that will help you implement that easily. If not, you can restructure that from iteration 1. How do we accept a session? So for instance, for a route that's like the quiz route, which would just be, I don't know, admin quiz, I think it is. Something like this with just, it'll accept a session. Yeah, let's leave it there for now. Oop. And a quiz name. This is just off the top of my head again. Check the spec for what it should actually be. And then let's assume we can admin quiz create, something like this, right? Assume it looks like this. Quiz name and quiz description. where do we get this session from? Well, we're not getting it from the request body, are we? Because we're getting it from the header. So instead of doing that, we can grab const session from request dot, any guesses? Instead of request dot body, someone whispered it, say it louder. Dot header, exactly. So very simple. And you can see in the spec here, it's similar to, okay, so I got it a bit wrong, but that's okay. You grab the session from the header object like this instead of unpacking it. I mean, I think both would work actually. This would maybe work, but yeah, it looks like that. Cool. So headers, what does a HTTP header look like? I wonder if I send it, if it will come up down here. Maybe not. Let's restart this server so that it doesn't have that error again and go back to our client. And V1 quiz, what did I call it again? Admin quiz. Admin quiz. Cool, and it expects a quiz name this time. Let's just give it a name. And it expects a quiz description as well. And give that another name. You can see here in your headers, you can add a header. Our header is called session, and the value, let's just pretend that that's a session, right? And then I should be able to, can't be reached. Oh, is it because it's on another port? 4913. 49153. 153. Try that. Okay, error. Oh yeah, that's because this is not defined. Okay, let's try and do this real quick. Function, quiz create, quiz name, quiz description, return, quiz ID. Cool. And then export admin, yep. And then we import that. From quiz. Okay, let's try that again. Now that it actually exists. Well, my little stub exists. Okay, cool. It's happy. It's accepted my session. And maybe what we can do to demonstrate that better, since it doesn't show up here, is console log it. Try that. No, maybe if I pop it. Oh. Let's pass it through here. Do that. Pass it to your backend. Again, what I said before, you might choose to pass your session object to your backend implementation, or you might choose to have something here that does like session to user ID or something like that, another method that takes a session. Completely up to your group how you decide to implement that. Try that again. Okay, there you go. You can see it now. So it's successfully grabbing the session from the API client header, and it's console logging it. But obviously you might want to do other things with the session, like figure out a user ID from that session. So yeah, in summary, implementation details are up to you, as long as you're passing the session through your HTTP header and the fact that you can have multiple sessions tied to a user. How you generate those sessions, how you store them, that's all up to you. Any questions on sessions? Why we have them, how to use them? Yep.
This isn't really about sessions, but how does a header work again?
So it gets sent, it's like metadata that gets sent alongside a request. So if I just inspect this page and go to the network and refresh it, oh, these are all HTTP requests, right? This is going to be quite small, but if I make it larger, you can see here I'm looking at a headers tab, a payload, and a response. The payload is your JSON body, right? That gets sent. That is the email, the first name, the last name, the password, right? And the response, you're used to that. That's your quiz ID. That's returning the quiz ID to the user or their user ID when they log in or create a quiz. The headers here, these are usually defined by sites to attach lots of information that you might want. I'm not going to show my full cookie, otherwise you'll all be able to get into GitLab and access the project solution. But you can see here there's some headers like defining the length of the content or defining, let's go down a bit. Yeah, like defining what user agent, what browser I'm using, right? That's all just information that you as the person writing a server might want to collect from people as they access your backend. You can think it might be useful to know if people are using Chrome or Firefox when they access your server, or maybe they're using an API client, or maybe they're using a Python script. And if they're using a Python script, maybe you want to limit the amount of requests they can send so they don't cost you a lot of money or something like that, right? So in our project, the only header we really care about, the only one we want to add is the session data. But in real life, you can think about tons of other things that you might want to collect that they're not related to the endpoint themselves. They can be kind of independent of that, but useful nonetheless kind of thing. Does that make sense? Yeah, it's kind of like, yeah, it's basically just metadata that you want to send with a request. But yeah, in this course, we only really care about authorization because that's kind of the most important header that you need to have a somewhat secure system running. But yeah, you can think of something like a user agent, which is just like what browser you're using to access an endpoint. Could be useful too. Any questions on sessions? Cool. Okay, so the next thing that I want to look at, let's quickly go over reruns because this is always a topic of concern. You haven't had reruns yet for iteration 1, but they're coming up. Reruns will start on Monday for iteration 1.2, which essentially lets you edit your code and potentially get a higher automark than what your initial automark run showed. The way you do it is via Git run. Hopefully you've all logged into Git run already to access your preview runs. So your band of like what automark you're getting. But if you haven't, you can log into Git run now and take a look at that. But this is where you submit a rerun. So how do you do it? For iteration 1, you'll have an iter1-submission branch in your backend. So at the top, you'll have, you've got all your branches. You'll have something that's like iter1-submission. If you branch off of that, make edits, create a merge request back into that submission branch, and then submit the merge request ID here, you can go for a rerun. Now, why do we have reruns and what's the point of them, right? Reruns, we have them because sometimes, especially with HTTP servers, you'll make a silly error like instead of admin auth register, you just do admin/register. It happens, right? You accidentally misread the Swagger, you misread the docs, and now you're failing all the course tests. Well, good thing for you is when you make an edit, like you just add in /auth to your server and then submit a rerun, you can get a lot of those marks back. Every rerun comes with a penalty. So for instance, for something like that, where you literally just add in /auth into a path, it's literally a 4-letter change to your entire project, that will only result in a penalty of say 5 to 10%. It's still a penalty because you didn't read the spec properly, but it's quite a minor one. Larger changes incur larger penalties. You can submit one rerun every 24 hours. So you theoretically, once the iteration 2 automarks come out, you could submit a rerun every 24 hours and try your very best to optimize your mark to get the highest automark possible. right? That's up to you, because by that point, iteration 3 will be out and you'll have bigger fish to fry, right? So it's kind of up to you how you balance your time with that, but it's mostly there. It mostly exists for people that make spelling errors, or they accidentally thought that sessions are numbers when they're not. Sessions are strings, things like that. Things that would make your auto mark, say for instance, 10 to 20 out of 100. And with that minor change, your auto mark will jump to like 80 or 90, because that's what makes the penalty worth it. But you can submit as many reruns as you want. We will only replace your mark if it's higher than your original auto mark. So that's just on reruns. Some other things, reflections. You should have already done individual reflections for iteration 1, but they continue for iterations 2 and beyond. Basically just there to reflect on the week that passed, note down what you worked on, note down any blockers. This does not need to be an essay. This can be 3 sentences and just, you know, whatever taskboard issues. You don't need to link every single commit. If you just link your 3 taskboard issues, enough to give your tutor an idea of what you worked on, that's fine. And then also you have all, most likely now, completed your first end of iteration reflection. You do another one for iteration 2. No surprise there. And you document who worked on what route. These are the ones that are based on iteration 1, and these are the routes that are new. So there's 1, 2, 3, 4, 5 new routes, which means you're going to have to make 5 new set of backend tests and implementation. But it's only 5. In iteration 1, you had to do, what, 11? 12? So you don't have to write as much new implementation code, but that's because we're giving you other work, which is the conversion of the iteration 1 backend implementation into a HTTP server, right? So workload-wise, it might not be larger, but sometimes conceptually, this can be trickier for people. So yeah, you need to do 1 new route per person, and this is in the spec as well. You can't have 1 group member do all of the conversion and then 2 group members work on the new stuff. You have to all work on the conversion and then do 1 new route per person. If you have a 3 or 4 person group, then one person can do 2 routes, and then maybe in iteration 3, they do slightly less work to kind of compensate for that, okay? But you need to do, at the very least, 1 per person. If we go back to the spec to make sure we haven't missed anything, editing your GitLab CI file, your pipeline, that just looks like, well, I'll open it here so that you can see it. Where is it? There it is. Okay, this is what the current pipeline definition looks like. It is just a YAML file, the same language that the Swagger docs are written in. And under this stage checks, you'll want to add in 2 new checks. 1 is for linting and 1 is for TSC. It's super straightforward. I'm not going to demo it here because it would basically be giving you the solution, but you can check the lecture slides as well. It's in there. So super easy. What else did I want to show you? The spec is quite large, is the other thing I will mention. It does get larger as the iterations go on, because sometimes the things from earlier help you out as you go. But yeah, try not to get too intimidated by it. We're just trying to give you as much information as possible. It's not an indication. The length of the spec is not an indication of the difficulty. We're trying to help you out with it. So that's why it's long. Something I'll mention about the versioning, because we get questions about this every term. Why does my endpoint need to start with a v1? Why can't I just do /admin/quiz? Does anyone want to have a guess, like why I might want to do that as a developer? Versioning, why is versioning important? Yeah. So you might want to change the way admin auth register works in the future. And generally, when you think about APIs on the internet, like there's a Spotify API out there, right? And you might be sitting at home one day like, I want to use a Spotify API to automatically make playlists for myself. So you go and you find an endpoint, it might be v1/playlists or something like that, and you post to that endpoint, right? And then Spotify are like, you know what? We don't like how we design that. Instead of accepting a playlist name and a playlist cover, we also want to accept a playlist description. But our initial API, the V1 version, didn't require that. So instead of one day randomly changing their server and adding in a playlist description, and now all of a sudden your Python script's broken because it's not sending the right user input, they say, no, we won't change the V1 playlist create endpoint. We'll make a new one called V2 playlist create, and slowly over time we'll redirect everyone to using that new one, and we'll deprecate the old one, right? So that your script at home now is not broken. It still works. At some point it might break, but not without Spotify sending you maybe like a bajillion emails saying like, hey, we're changing the endpoint. If you don't want your script to break, move to V2. And then that gives developers time to look at changes, have their stuff still work, and migrate at a time that suits them. So in our project, we start with V1, and then in iteration 3, some of our root definitions might change. And in that case, we'll make them V2. Okay, so that's why you need to put V1 at the front of your root definitions. We've been through user sessions. Error returning, I mean, you've already been taught what error status codes are. You've probably seen them all over the internet when you've gone to access things as well. The spec does give you how do you set the status code. It's also in the server example we just did. And how do you stringify those error codes as well. So nothing new there. We've kind of already been through that. One thing I will mention though is that errors need to be returned in the following order: 401, 403, and then 400. Does anyone want to have a guess as to why 401 and 403 would come before 400? Maybe a simpler question is, does anyone know, oh, it's literally on the screen, I'll scroll down. Does anyone know what 401 and 403 errors usually represent?
Is it because 400 is like associated with create, and then 401 and 403 is more like get, and like kind of like a lower order error? If that makes sense.
Not quite, but good job having a go. Yeah?
Not found, isn't it?
What is it?
Found.
Not found.
Isn't it 401 not found?
404 is not when the page isn't found. 401 is, yeah.
401 is unauthorized?
That's, yes. So 401 is unauthorized and 403 is forbidden. What's the difference? 401, does anyone know the difference? It's quite hard, yeah?
One, you aren't logged in, the other, you don't have the right.
Perfect. 401, you're not logged in. 403, you don't have the permission to do the action that you're trying to do, aka like you're not an admin user or something like that. Right. So when you think about why we might want to return a 401 and a 403 before a 400, it's probably good practice if you have a special admin panel that has fancy admin capabilities on it. You want to tell the user they're not logged in first rather than say, oh, you haven't given me the right parameters, which is change student grade and give them a new title or something, right? Because that would give an attacker like more information to know what to do with your API. You just want to say, hey, you can't do this if they're not authorized to do it. So that is why the errors need to be returned in that order. First, you're not logged in because we don't want people that don't even have an account to be able to see what to do. And then 403, aka you're not an admin or you don't have the right permissions to do that action, or maybe it's someone trying to edit a quiz that they don't own. Need to tell them that first before you tell them that the quiz title they've provided might be a bad input, like it's a number 1. That's not a quiz title, right? So that's why you want to return those errors in that format, in that order. So you need to think about that when you're implementing your server as well. You want to return 401, then 403, then 400. We've already been through how to run your backend with the front end. So that's been covered. We have some hints in here, which is essentially what I went through with my demo. The only thing I left out was HTTP tests, and we'll have a quick look at what those tests look like. This has already been covered in the lectures. It's really no different, but I will show you the difference between, okay, on the left-hand side where you have, this is an iteration 2 test file, and the right-hand side is an iteration 1 test file, okay? So iteration 2, the only difference is you can see instead of calling echo directly, the implementation directly, you're calling the root. Just like an API client is hitting your server, you can hit the server with sync request curl and do the same thing. But we've been through this already in the lecture, so I won't go over it in too much detail. A couple questions I'll answer that generally comes up is, no, you don't need to rewrite all of your iteration 1 tests. Like, you don't need to edit this file, right? We've got echo direct. You don't need to go in here and change the file. You can just write a new file, which is like, in this case, it's new echo.test.ts, but you can name it whatever you want. And these tests, your original iteration 1 test, should still work. Why? Because you haven't changed anything about your implementation from iteration 1. All you've done is build on top of it. You've just exposed that implementation via a server. So you can write new tests that check that your server definitions are correct, and that's what you should do to make sure that everything works. But you don't need to remove, and in fact you shouldn't remove, your original iteration 1 tests. Yeah?
For the new functions, do we need to make new backend tests?
No, you can just write HTTP tests for the new ones. Yeah. So like iteration 1, you want to write your tests before you write your implementation though, right? So make sure you keep that in mind. Yeah. There's some hints in here, which I think we've, already been through, but definitely give it a read. Marking criteria, also worth looking over. Auto marking is weighed slightly more heavily this time around. And down here is your new 10% that's dedicated to whether or not the front end works with the back end. So that's worth checking. Your auto mark, 95% of your auto mark comes from the combination of your tests and the hidden course auto tests that you don't get to see. Combined with 5% of your mark is ESLint. This is meant to be easy marks because you can literally just run like, if you run npm run, I think it's in my, yeah, it's in here. npm run lint fix. It'll fix like most of the errors, and then the 9 that it can't fix, you can just go through and fix yourself. Like, for instance, here I used double equals somewhere instead of a triple equals. Just go in and change that. It's supposed to be super simple. So that's linting. The dry run, there is a dry run for iteration 2, just like there was for iteration 1. It won't be as useful as, for instance, just running your backend with the front end, because the front end tests everything, whereas when you inspect the dry run, we only call a couple of your routes. And one thing I will mention, because of all of this, if you want to run your tests, because some students get caught up on this as well, even though you do it over and over. I will stop my front end from running. You need to run your server first, and then your tests in another terminal, right? Because your tests are hitting the server. You can't run your tests without the server running, okay? So if I run here, npm run test, we should get passing, yes, because new echo, you'll see new echo passes because new echo is hitting the echo endpoint. That's the HTTP test. But the old one still passes too, because nothing's changed with the backend implementation stayed the same. Right, we haven't touched it. Okay, any last things from this? Teamwork evaluations, the same as iteration 1. So there's nothing new there to add. We've already been through reruns. Your project check-ins haven't changed. Reflections, all that, yep. Previews. Yeah, last things, just I guess to mention, like with all the iterations, don't use LLMs. I know you might be tempted to. You can use them to help you explain concepts if you're stuck with something, but don't ask it to do the project. Why? You have a final exam, and if you can't do the project by yourself, then you probably can't do the exam, and you'll probably fail the course. So that's just my advice. If you get through the project and you can do your routes, you'll be fine for the exam, okay? So that's my incentive for you to just do the work yourself, because you'll thank yourself in 5 weeks or so when you're sitting in that exam room. You're like, I remember having to do this myself for the project. Not saying I know what's in the exam, but you know, that's just piece of advice. So yes, iteration 2. Converting your iteration 1 backend implementation into an actual backend of a server, HTTP server. Any last questions? You can always post them on the forum. We've got tons of help sessions as well if you get stuck. Cool. All right. Well, thanks everyone. Yeah.